First, let's define a nerve impulse. It's a quick change in membrane potential of sodium and potassium that travels along an axon. Initially, there are greater concentrations of sodium outside of the cell and greater concentrations of potassium inside the cell. The potassium tends to diffuse out of the cell, which causes the charge potential across the plasma membrane, which is about 70 millivolts. Sodium, meanwhile, tends to diffuse into the cell, but at a slower rate due to the low permeability of the plasma membrane to sodium. This is the resting potential. At this point, it's considered polarized. The action potential is the movement of ions in and out of the neural membrane. There are two phases: depolarization, change from negative to positive in axon, and repolarization, change back from positive to negative in the axon. During depolarization, the neuron is stimulated and the membrane potential rises. When 50 millivolts is reached, the voltage-gated sodium channels open, which allows sodium to enter. This occurs until 30 millivolts is reached. During repolarization, the inside will become negative again and the outside positive again because the membrane potential peaks and the sodium channels close while the potassium channels open. The potassium diffuses down the gradient until it is well below negative 70 millivolts of resting potential, which is called hyperpolarization or undershoot. The nerve cannot send another impulse until the action potential has been restored. The time it takes for the neuron to send an action potential and repolarize is called the refractory period, after which it can send another impulse and the process can start over again.